Hi, in this lesson we're going to talk about the fourth unit of AP Statistics, randomness and probability. The topics that will be covered in this unit are probability rules, random variables, probability models and probability models and distributions. Beginning off with our vocabulary. What is a trial? A trial is just an observation of a random event. Now what's an outcome? It's the end result of a trial. So for example, a trial could be the toss of a coin. The outcome could be what happened after you toss the coin, so you could get a heads or a tails. Sample space. Sample space is the collection of all possible outcomes of a trial. So if I flip the coin twice, the possible sample space are two heads, a heads and a tails and a heads, and then two heads. The law of large numbers. Now this might be the only thing that will come up a lot and also has a lot of meaning to it. So it just means as the number of trials increases, the probability of an event approaches a single number. So that means for example, if we flip a coin 1,000 times, we'd expect the probability of a heads to be 1/2. However, if you flip it 2 times, the probability of getting a heads could be less than 1/2 or more than 1/2. But as the number of trials increases and goes towards infinity, the probability gets closer and closer to one number. So, for example, as the number of trials increases, the probability of getting a heads is 0.5. Next, we have the law of averages, which is something that doesn't exist. Honestly, it is what people use to try to justify their short-run expectations. So it is a supposed short-run law for the law of averages. Numbers comes up a lot in the AP exam. However, the law of averages does not. There's no supposed short-run law for the law of averages. It doesn't mean, for example, that since you've gotten 4 Fs in a row, you're due for an A+. There's nothing like that. It doesn't exist. Talk about the expected value, which is just the value that you would expect after a certain number of rounds. So over here given is a probability table. As you can see, this refers to X, which is some number of trials, so the occurrence of something up to 4, and this is P of X, which is just the probability of X. So these probability of X, so I'm going to refer to it as P of X, must sum up to 1, right? You can't have a negative probability in any of these. If let's say this was a negative 0.05, this would be invalid, or if this was negative 0.2, it would be invalid because the probabilities no longer sum up to 1. So how do you calculate expected value? So given here is the expected value, and amazingly enough it came up to 1. So how you calculate is X times P of X for each one of these, and you keep adding it. So as you can see, 0 times the probability of 0 plus 1 times the probability of 1 plus 2 times probability of 2 plus 3 times probability of 3, and so on. So you get 0 times 0.05, 1 times 0.1, 2 times 0.6, 3 times 0.12, 4 times 0.13. This final answer might be off now looking back on it. That 1 was meant for the probabilities. So the expected value comes out to be at 2.18, which is a lot better. So as you can see, it is just multiplying these and summing it up. Next we're going to talk about is probability. I've used the word multiple times already, but this just means the likelihood of an event occurring. It has a range of 0 to 1. So the probability of any given outcome or trial can range from 0 to 1. It can't be above 1. 1 just means that it's 100% likely, and 0 just means 0% likely. There are types of probabilities as well. Or disjoint just means that if two events don't have any outcomes in common. For example, flipping a coin and expecting a heads and a tails. The occurrence of a heads and a tails on a single flip is 0. You can't get both. Next is independent. If two events do not impact the outcome of each other, we'll say they're independent. So for example, doing well on a test and how fast you can run 1 kilometer. They don't impact. However well you do on your test does not dictate how fast you can run your 1 kilometer generally. Now, if there are two events that are not independent, so if two events are not independent, we don't say they're dependent. We just say they're not independent. So we don't say they are not independent. Sorry, we don't say that they are dependent. We say they are not independent. You say not independent. So you say not independent. Because just because they're not independent does not mean that they're dependent. Now look at this section over here, which is complement. So if I have two events, A and B, the probability of A plus the probability of B must equal 1. Therefore, if I had to find the complement of B, it is just 1 minus the probability of A. It's very simple. It's something more probability related. We're going to talk about the formulas. So this first formula, I assume most of you have seen before. It just means that the probability of A or B occurring is the probability of A occurring plus the probability of B occurring minus the probability of both of them occurring. So if I flipped a coin twice, so if I ask what's the probability of a heads occurring or a tails occurring, so I would check the probability of receiving a heads, which would mean a heads or let's make it simpler. Let's say we had one flip. So if I wanted to find the probability of a heads or tails occurring, I'd find the probability of a heads occurring, which is 1/2, plus the probability of a tails occurring, which is 1/2, minus the probability of neither occurring, or sorry, both occurring, which in this case ended up being 0. But next we have is this. This may not be as common to you, but it still is very important. It just means the probability of A given B, which is equivalent to the probability of A and B divided by the probability of B. So if I say what is the probability of a heads occurring on the second flip given a tails occurred on the first one. So first you want to figure out the probability that a heads occurred on the second one and the probability that a tails occurred on the first one, and you divide it by the probability that the tails occurred on the first one. Now if two events are independent, this is also very important. The probability of A and B occurring is just the probability of A multiplied by the probability of B. Now, when we go back to the coin flipping example, coin flips are independent. Getting a heads on the first one does not indicate anything of the second one. So we would say that the probability of getting a heads on the first one, heads and tails, is on two separate flips would be the probability of getting a heads on the first one multiplied by the probability of getting a tails on the second one, which is 1/2 times 1/2, which is a fourth. Diagrams. Diagrams are very important in understanding and visualizing probability structures. The first one we're going to discuss is the tree diagram, which is just a display of conditional events. So what this bar just means is the opposite of. So in this one, we look at the probability of A in one bar and the probability of not A in the other. So after getting the probability of A and not A here, you can have probability of B given A, which gives you this, or the probability of not B given A, which gives you this. It's very simple to understand. Now if I wanted the probability of A and B in this situation, I'll just multiply these values that would come out here. And similarly values that came out here and here. You may have seen the Venn diagram, created by John Venn. It's just a diagram that shows all the possible outcomes and all the possible outcomes of different collections of sets. So in this Venn diagram, you have A, which is green, and B, which is blue. Now, the combination of these would be A or B. In some Venn diagrams, you would have a small little circle outside for values that are neither A nor B. And this inside intersection is what we call A and B, which you saw as referred to A with the upside down U, B. Already in the first two chapters, and now we know what it is. Know that standard deviation is the square root of variance, and variance is just a spread. I want you to try and see if you can figure out what these values could be, and pause the video and try that out for yourself. You probably got these ones correct, the expected value. So if I had the expected value of getting heads plus the expected value of getting tails, I would just add them together, and if I had to subtract them, subtracted it. Same goes for multiplication. If I had to get the expected value of getting 100 heads, I would just get the expected value of getting 1 heads and then multiply it by 100. Variance is a bit more tricky because if I have the variances of two things, regardless of whether I'm subtracting or adding in this kind of form, I will always be adding them together. And for variance of any multiple constant, when I multiply that by the variance of x, I will get a square there. It is because that once I square variance is standard deviation squared, when you actually look at this, you get your a squared times standard deviation squared, which is a times standard deviation squared, which makes sense. About Bernoulli trials, which is another way of calculating probability. In a lot of your other math classes, you may have heard of it as, say, the binomial model or the geometric model, but we're going to elaborate on it and make it a more general idea. So Bernoulli trials are just trials where with exactly two outcomes, a success and a failure. There are three conditions for when you can use Bernoulli trials. There have to be two possible outcomes as stated above, which is your success and your failure. The probability of success is constant and your trials are independent of each other. Now what do I mean by these? So when I say two possible outcomes, I'm going to go back to the coin flip again because this is a very simple example. So with coin flip, you can either get heads or tails. You can't get heads and tails, but you can get either or. Now what do I mean by probability of success is constant? So if we say heads is our success, the probability of heads, if it's a proper coin, is always going to be 0.5. Whether we flip it once, twice, 100 times, 3,000 times, a billion times, an infinite number of times, it is still 0.5. Next, the trials have to be independent of each other, which means getting a heads on this flip shouldn't affect the next flip. So this just means that if I get a heads on this flip, the next flip should not be impacted by this. I still have a 50% chance getting a heads or a tails. Now what are the conditions for this one? So we need to look at the sample size is less than 10% of the population. This is so that we have a small population, a small sample to work with. Otherwise the numbers could be extraordinarily large. The next one is greater than or equal to 10 and n of 1 minus p greater than or equal to 10 or approximately normal. So what do I mean by n and p? N is the number of trials and p is just the probability of your success. 1 minus p, also sometimes referred to as q, is the probability of failure. So if I flipped a coin 20 times, the probability of getting a heads is 1/2. So 20 times 1/2 is 10, which is greater than or equal to 10. And 20 times 1 minus a half is 10 as well, which is greater than or equal to 10. We do that to ensure that there's no skewness in the data. Geometric model is a model that will help you predict the probability of getting a first. So I'm going to use all these examples and use them with coin tosses because they're very easy to understand. So let's say getting a heads is a success. We all know the probability of getting a heads is 0.5. The probability of getting a tails heads, which is again 0.5. So if I want to get our first heads on our third flip, that means our first two flips have to be a tails and the third one has to be a heads, which I represented like this. In general, we can write it as this formula. So the probability of my heads on whatever number of flips would be 1 minus the probability raised to n minus 1, which would be, in this case, 3, multiplied by that probability. So in this case, we would do it as the 1 minus probability of the heads, which is 1 minus 0.5, raised to 3 minus 1, which is 2, times 0.5, which is this exact value. Now, when we talk about expected value or mean, it would just mean that how many of these successes would you expect in the number of flips? Or how many would you expect in general? So when you're looking at this, it's just 1 over the probability of your success. The value comes from this, which is generally just 1 over the probability of your success, which ends up being 1 over 0.5. And your standard deviation is this. As I mentioned above, this 1 minus p can sometimes be referred to as q. So if you ever see square root of q over p squared, just remember it means the same thing and that there is no difference. Discuss the binomial model, which is getting n number of successes in a defined number of trials. So again, with the coin tosses, let's say getting heads is a success. Probability of tails is 0.5. Now what if I wanted to get exactly one heads in 2 flips? And the key word over here is exactly. If I said the probability of getting one heads in 2 flips it's very vague because it doesn't mean exactly one heads, doesn't mean at least one heads, it's very vague. So we say exactly. So exactly getting one heads, I drew in a tree diagram, would mean if I get a heads on my first flip, I have to get a tails on my second. If I get a tails on my second, I have to get a heads on the first. This rules out because this is 2 heads and this is 0 heads. So as you can see, if we did tree diagram, this portion would be 0.5, 0.5, 0.5, 0.5, 0.5. So when you multiply it across, you get 1/2 times 1/2 plus 1/2 times 1/2, which is 1/4 plus 1/4. So in general, a binomial model can be represented like this. So if I wanted to get k successes in n trials, it will be n choose k, which as you most of you know, but I will go over it at the end of this lesson, multiplied by the probability of success raised to the kth power, multiplied by 1 minus the probability raised to the n minus k power. So in this case, if I wanted to get one success in two flips or 2 trials, so it would be 2 choose 1, which is 2, multiplied by probability of a success, which is 0.5, raised to the 1 power. So we're right now at 2 times 0.5 times 1 minus 0.5, which is 0.5, raised to the 1. So we get 0.5 times 0.5 times 2, which is 1/2. Now for expected value for this one is a bit more different. It's NP, which just means the number of trials times my probability, which is a bit more accurate because the expected value will change based off how many trials we do. So in this case, we have 2 trials and the probability of a success is 1/2, so my expected value is 1, which is 2 times 1/2. My standard deviation is the square root of NPQ. I'm going to refer to this as Q sometimes and 1 minus P sometimes. So it'd be the square root of 2 times 1/2 times 1/2. I would talk about this NCR or above NCK. It just means choosing all possible outcomes from a set of n trials, or rather outcomes, I should say, n possible things from a set of n trials. So I'm going to assume that you guys may have heard of this. So this is the common notation. It's just n factorial over n minus r factorial times r factorial. So if, for example, I had 4 things and I had to choose 2. So 4 things, choose 2. I don't care what order it is. That's when you use choose. So you would write this as 4C2, right? So 4C2 sometimes, or you could also write it as this, which just reads as 4 choose 2. It's not that difficult to remember, and your calculator can do most of it when you type in n capital C R and then you put your values in. Now I want you to try the questions given below to try to figure them out yourself. So the first one asks, what is the probability of getting exactly 3 heads followed by 1 tails, exactly 3 tails in 4 flips, and a tails or a heads on a flip? You may have to use the geometric model, the binomial model, or any probability models we have used, maybe in that order, maybe not in that order. Final one, which would also be a good indicator of how well you know your stuff. Pause the video and try it out first. So for the first part, the first question, we have 3 heads and then 1 tails. So that'll be the probability of a heads on the first one, a heads on the second, a heads on the third, and then a tails on the fourth, sorry. So it's 0.5 times 0.5 times 0.5 times 0.5, which is 1/16, or you could put it in decimal form, completely up to you. That is a very simple one. We're going to go to a more difficult one. Exactly 3 tails in 4 flips. So these are your number of trials, and these are your successes. So you got 4 choose 3. Then you're going to multiply it by the probability of your success raised to this number. So 0.5 to the 3 multiplied by the probability of your failure raised to n, which is your number of trials, minus your number of successes. So you get this sort of equation. then 4 choose 3 is 4 factorial over 3 factorial times 1 factorial. If you didn't understand that, then you could do it as 4 minus 3 factorial if you understand that better. You'd get this value of this as seen from above, as the above question, gets you 1 over 16. Sorry, not the 4 choose part, but solely this part will get you 1 over 16, and then this section with the factorials will get you 4, so you get 4 times 1 over 16, which is 1/4. So I actually made a mistake on this one. This should have been an and, not an or. But if you did tails and heads on a flip, it is 0. If you do tails or heads, which actually I'll add in on a flip, you will get the answer to be 1, because there are the only two possible outcomes. You can either get a tails or you can get a heads. Both will give you 1 exactly. Probably the hardest of the 4 questions. Maybe the heads and tails one maybe have got you, but that was my mistake. I completely take ownership for that one. So this one, probability of tails, I would have to say tails on the second, which would be a better description, given heads on the first. So this is the syntax for it, right? Tails given heads. And if you remember, it is the location where these two intersect divided by the probability of this, which is probability of tails in the second and heads in the first divided by probability of heads in the first. The best thing to do would be to draw a tree diagram. So I'm going to quickly scroll back up to the original tree diagram. Forget the highlighting marks for a second. So we're looking at the probability that you had a tails on the second given and that you had a heads on the first. So that'll be this section over here. And since this has a probability of a half, this has a probability of half, you get a total probability of 1/2 times 1/2, which is 1/4. Represent 1/4 as 0.25 because it just made it easier. Now, the probability of getting a heads on the first is the probability of getting a heads on any other flip, which is always going to be 0.5 or 1/2. So when you do this, you end up with 1/2 or 0.5. Hope you got those questions right, and I hope this is very valuable. Thank you so much for watching. Till next time.